Hi, Math 1 students. Mrs. Robinson here to work Practice Benchmark Chapter 7 with you. I'm going to go over these problems, and when you need help, you can come here, fast forward, rewind, get a little help on these Practice Benchmark problems if you need, after you, of course, have gone through the chapter and done the assignments. All right, drawing a net. A net is a two-dimensional way to draw a three-dimensional figure. Kind of think of it like origami, right? You're unfolding it or you're folding it up. So let's start with the base. The base is a rectangle, okay? And I need to label it. So I'm going to label it 8 centimeters by 14 centimeters. Now, depending on how I cut this, let's say this was a cardboard box and I sliced it here and here, and then I sliced it here and here, and the triangles fell out like this. It would look something like this, and I apologize for the ugly drawing here because I'm doing it freehand. Okay, and so this side piece would be 12 along with this, and then if I cut the other side over here, this side piece is also labeled 12 centimeters. So when I do that and those side pieces fall out, those triangle pieces, here is going to slice right here and open this way. So I'm going to have, let me see if I can do another rectangle right here. Okay, and that is going to be labeled. And then I'm going to slice this one and fall this way. And so I'll have another rectangle here. And this is one way to draw this. There is more than one way to draw this. Okay, and so when I slice it, this length here is still 14. The side length here for these rectangles are going to be 12. And the side length here will also be 12 because it's labeled here 12 centimeters. So when it opens up, this side length will be 12. This will be 14 again. And this will be 14. And there you have it. There's your net. Two-dimensional figure or drawing for the three-dimensional figure. All right, let's go on to number 2. Name 3 collinear points. So you have to understand what collinear means. Think co meaning you're sharing, like a co-pilot, and linear means on a line. So collinear means they all have to lie on the same line. So name 3. A, N, X would work. A, oops, it's not working. A, comma, N, comma, X. Those are 3 collinear points. C, N, M. C, comma, N, comma, M. Those are 3 collinear points. R, N, if there was a third on this line, we could do it, but the dot means it's underneath that plane. Okay, guys, I went back and added a little explanation for this picture. You can see that this line is piercing through this plane. It might look like this line is on the plane, but it pierces through. So in the photo RN, this line pierces plane V vertically. It's not lying on the plane. So just make sure you see that in the picture. All right, what are 2 other ways to name plane V? So we can name it plane V, or we can name it by 3 non-collinear points. You can't name it by 3 collinear points because then it would be confusing about, are you naming the line or the plane? So you need to have 3 non-collinear points. So we could name this A, N, M. That would work. Plane A, N, M. These 3 are non-collinear. Or maybe we could go A, X, C. That would work. A, X, C. So you can name it plane AXC. There's several other ones you could do. How about CNX? You could do that. CNX. AMX. You could do that. Anyways, those are 4 different ways. AMX, and we'll just call that plane AM and plane. All right, on to number 4. Our points are N, M, and X coplanar. They're co-pilots. They're on the same plane. So R is up here. Remember, this pierces through this plane. It's not lying on the plane. It's hard to tell in this picture, but that's dotted. This person is through the plane, so R is not actually on this plane. So because R is not on the plane, N's right here, M is, and X is, these are all on the plane, but this pierces through. Because R is not on the plane, these are not coplanar, so I would say no. And that really is hard to tell in that picture, and that's why I added that, just so you can see that. Okay, determine whether each statement is always, sometimes, or never true. These can get tricky. Okay, so number 5, does plane X, Y, or plane X, Y, Z does not contain point Z? Well, if it's plane X, Y, Z, that means those are 3 non-collinear points on the plane. Just draw X, Y, Z. Okay. Plane XYZ does not contain point Z. That's a never. Okay. Because it does contain point Z just by its name. So that would be never true. It says it does not. Well, that's never true. It does. Okay. 2 rays that share an endpoint form a line. So let's just draw that. If they share an endpoint, let's say this is point D, and this would be F, and this would be A, D, F. Do they form a line? That would be true in this case, but what if I had a ray DF, and they share endpoint D, and then I had a ray that went this way, DC. Well, they share the same endpoint, and these 2 rays are going to make an angle, but they don't make a line. So in this case, it would be true. These are opposite rays. In this case, they share the same endpoint, but they don't form a line. So that would be a sometimes. Okay, that's a sometimes for number 6. All right, number 7. Name the intersection of planes E, F, G, and A, D, H in the figure to the right. All right, let's clear this off and scroll up. Hold on a second. All right. Make sure when you do these always, sometimes, nevers, guys, that you draw out a picture of possibilities. That will help you answer that. So let's look at this, the intersection of plane, and I like to just highlight what I'm looking at. I'm looking at EFG, so this plane right here, okay, and ADH. Here's A, and maybe I'll do this in blue. Here's AD and H, so it'd have to be this plane right here. All right. Name the intersection. Well, it looks like the blue and the red cross over at segment EH, and there's my intersection. Okay. Let's look at how many planes contain HM and F in the diagram. Hold on. Okay, so I like to highlight what I'm looking at. HM, here is line HM. I'm going to highlight that in blue. If I can get it to pull up, or in red. It's red. Here's HM and point F. Well, where's point F? Right here. How many planes contain HM and F? Well, if I need to draw a plane that will touch both HN and F, can I do it? Well, I have a line. Let's just draw the line out here and not anything to do with this figure. There's line HM, okay, and here's point F. Is it possible to draw a plane through a point not on a plane and a line? Sure, it surely is possible. It would look something like, you know, I come up and hit everything like this, okay? And I should have hit that too. Let me try that again. I should come up with something like this, where I hit that point and this line, or I can go through the line and through the point if you want. Okay, remember a plane extends on forever in each direction, all right? Now, is it necessarily one of these sides of this figure? Not necessarily, but I can draw a plane through there. So how many planes contain this line and this point? Just one plane. All right, on to number 9. Let me clear this off. All right, this one's simple segment addition. They tell Okay, so number 9 is simple segment addition. They tell you the measure of, and there's no bar, so the measure of GH means the measure of is 45, and the measure of GI, so that measurement, that segment is 61. And you just have to find HI. This is simple segment subtraction or addition. I need to find this section. You could call this X and go 45 plus this section X should be the total 61. Or I'm just going to go 61 minus 45. And I'm going to get 16, and that would be the length of HI, that segment length. Let's do it like that. Okay, let's look at number 10. Number 10, let me scroll up. Hold on a second. All right, number 10, they say the measure of KL is, let's just mark it, 8x minus 5. So that's KL, this part here. And then LM is, the blue part here, is 6x plus 3. And then they want us to find KM, the whole thing. Okay. They didn't give us actual numbers. They want us to find the whole thing. Well, they did give us some markings, which is helpful. They told us this was congruent to this. So in order to find the whole thing, first I need to figure out what X is, because I don't have an actual amount. I can figure that out because this is congruent to this. I can set these equal to each other and solve for X. So I'm going to do that. I'm going to come over here and go, all right, well 8x minus 5 is going to equal 6x plus 3, and I'm going to solve for X. Do your solving, add 5 to both sides, simple algebra here. And when I do that, I'm going to bring down, I'm just going to write over this. I'm going to bring down 8x, I'm going to bring down my equal sign, bring down 6x, and then 5 and 3 is 8. Now I want to get x by itself, so I'm going to subtract 6x to this side, 6x's, and I get 8x minus 6x, and I'm going to go down here and get 2x, bring down your equal sign, equals 8, then divide by 2, and you're going to get, that eliminates, you're going to get x equals to 4. Now I've solved for x, I can come in and plug it in for x in either one of these. I should get the same thing. Let's plug it in here. So I'm going to go 6 times 4 plus 3. Well, 6 times 4 is 24, plus 3 is 27. You can plug it in here. 8 times 4 is 32. Sorry. 8 times 4 is 32, and 32 minus 5 is 27 also. So this is going to be 27, and this is going to be 27, and I add them together, and I should get 20, 40, and 14, 54. And there's your segment KM. All right, on to the next one. Okay, so number 11, suppose x has a coordinate of 5 and xy equals 10. What are the possible coordinates of point y? Now this doesn't have something drawn out for you, but they're referring to a number line when they say x has a coordinate of 5. Draw out the number line so you can get an idea of what you're looking at. If this is 0, 1, 2, 3, 4, 5, this is 5, 6, 7, 8, 9, 10, this is 10. Did I count that out? Okay, so if x has a coordinate of 5, here's x. It has a coordinate of 5, okay? And I know xy is equal to 10. That distance is 10. So if I start here at 5, that is my point. That's where x is. And xy, that segment, is equal to 10. That means from here I had to go 10 this way or 10 this way. So if I go 10 this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry. Here, this could be y, because then that distance, xy, that distance would be 10. Well, what is that right here? What's the coordinate of point y? Well, if I went 5 more this way, it would be 15. So this segment would be 10. Or I could have gone 10 this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this could be y, because this distance here would also be 10. this distance here would be 10. So y could have been here or here. And what's the coordinate here? -5. I went beyond 0, 5. So this is a possibility for y here. Let me do it in red. This could be y, or this could be y. They're both 10 away. So what are the possible coordinates? Y could be -5 or 15. And there you have it. Draw out your number line for that one. All right, guys, this one's similar to number 10, a little different. If RO, that's this section here, is 5x, and then they tell us the whole thing, RQ, is 12x minus 20. Now we need to find x, and then we need to find RO, OQ, and RQ. So we just need to find all the pieces. So let's look at what we have. If we know that this is 5x, they told us this is congruent to this. Use that. If these segments are congruent and that's 5x, well, this must be also 5x. And this plus this is going to be the total. So now I get an equation I can set up, dun, 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 and I can solve for x. So this plus this is the total. So I'm going to do that. 5x plus 5x equals my total, which is 12x minus 20. Simplify this side because these can combine to make 10x's. 10x's equals 12x minus 20. Get your x's together. I'm going to subtract 12x to this side. I'm going to get a negative x, but it's okay because that's a negative. So 10x minus 12x is negative 2x, and that's going to equal negative 20. Now to get x by itself, I'm going to divide. I'm going to have to go below this. I'm going to divide by negative 2 on both sides. And then I'm going to get x equals a negative divided by a negative is a positive. So 20 divided, or negative 20 divided by negative 2 is positive 10. Now I've done the first part. I found x. It's 10. Now I need to find RO. Well, RO is 5x. If x is 10, I plug in 10 here, and I'm going to get RO, which is going to be 50. Now OQ should be the same, 50. Okay, so I have 10 for that, 50, and then the total, well, 50 plus 50 is 100. So I want to see all three answers here and the answer here. All right. Let's go ahead and move on to number 13. Okay, we have angle J, let me scroll down. We have angle JKL, so JKL. We know it's a right angle. Ooh, that's good information. I should mark that. Okay, that is a right angle. What are the measures of JKM? So this little guy right here, this piece, and MKL, this piece. So I want to know what this piece and this piece are. Well, I know this piece is 12x plus 3, and I know this piece is 6x minus 3. I don't know what x is. If I did, I could know what that is and that is. But I know this is a right angle, so it's 90 degrees. So set up an equation. I'm going to go 12x plus 3. Let's try that again. 12x plus 3. So this plus this, 6x minus 3. So that angle plus that angle has to equal the 90, equals 90. Now I can solve for x and figure out what everything is. So do the math on this. Let's simplify one side by combining like terms before we work both sides. So 12x's plus 6x's are 18x's. And 3 minus 3, well, that's just 0, so cross those out. So 18x's equals 90. Now to solve, I'm just going to divide both sides by 18. And I can do 90 divided by 18, and I'm going to get 5. I don't know my 18s. All right. So x is 5. Now I found x. I haven't solved the answer yet, or answered the question, I should say. I'm going to put in x for here, and that's going to tell me the measure of JKM. So if I want to do 12 times 5, I'm going to get 60 plus 3. I'm going to get 63. So JKM is 63 degrees. Now I just plug it in here. 6 times 5 is 30 minus 3, 27. And there you've solved both, 63, 27. All right, let's go on to the next one. Measure of, we want CGD. So this guy right here is 2x minus 2. Right, this angle right here. And then we have EGF. This guy's 37. And then CGF. Sorry, CGF. The whole thing. Okay, so from here all the way to here, the whole thing is 7x plus 2. Now, in order to figure out this one, we have to solve for x. This is a little tricky with the markings. This looks like it's one whole mark, but it goes over both angles. So what they're marking here is they're telling you that this right here is congruent to this. That's what those markings mean. This is congruent to this. So if that's 37, this is also 37. So know your markings, okay? It went over both angles. So what they were really trying to do here is mark it like this. That and that are congruent, okay? So let's set up an equation. And, oh no, I lost all my markings. All right, this was 2x minus 2. This was 37. This was 37 because these are congruent. And then the whole thing here from CGF was 7x plus 2. Sorry about that. Okay, so let's set up an equation to solve for x. So we're going to go 2x minus 2, so this angle, plus this angle, plus this angle is going to be the whole angle. So 2x minus 2 plus 37 plus 37 is going to equal the whole thing, which is 7x plus 2. Now I can solve for x. Just do your algebra. Let's first combine everything on this side. If we go 37 plus 37, let's see, 3 and 3 is 6, 7 and 7 is 14, so 60 plus 14 is 74. 74 minus 2 is 72. So on this side we'll have 2x plus 72 equals 7x plus 2. Now we can start working both sides of the equation. Let's go ahead and subtract 72 to this side. And by doing so, we'll bring everything down. 2x equals 7x. That looks like 22, but that's supposed to be 72. Right. 2 minus 72 is going to be negative 70. Now let's move the x's over to this side. So subtract 7x from both sides. That eliminates that. 2x's minus 7x's are negative 5x's. Bring down the equal sign, equals negative 70. Now to solve for x by itself, I divide by negative 5 on both sides. And that's going to leave me with x equals a negative divided by negative is a positive, and 70 divided by 5 is 14. So I've solved for x. That's all they asked me to do here is solve for x. So your solution is 14. If it asks you to find the measures of the angles, then you go plug this in. You already know these two, but that's all it asked you for this one. All right, let's go ahead and go on to number 15. It says, use the diagram at the right to determine if each statement is true. So let's look at this diagram. Remember, a straight line makes 180 degrees. If this is 90, this also has to be 90, okay? It looks to me like angle 1 and angle 4 are vertical angles. So angle 1 and angle 4 would be congruent. So let's analyze it before we start answering questions. So let's look at number 2. 2 and 5 are adjacent angles. Is that true? 2 and 5. Well, 2 and 5 aren't necessarily adjacent. Adjacent means next to. Okay, so angle 1 is adjacent and angle 3 is adjacent. Angle 2 is not adjacent to angle 5. So that I would say false. Okay, angle 1 and angle 4. Are they vertical angles? Yes, they are vertical angles. Look at the lines they share. Okay, 2 intersecting lines. They are vertical angles. Yes, so that is true. Angle 4 and 5 are complementary. Remember what complementary and supplementary mean, okay? Complementary means they add to be 90. Supplementary means they add to be 180, which is a whole line. So let's look at angle 4 and angle 5. Are they complementary? Well, angle 4 and angle 5, if you look at it this way, they add up to be a whole line. So they would be supplementary, not complementary. 3 and 4 would be complementary because they make 90, but not 4 and 5. So that would be false. All right, there we go. Let's go on to 18. Okay, this one we weren't given a picture, so let's first draw a picture. QR bisects angle PQS, and that little line should have been over the QR, not the PQS. Sorry about that. So let's go ahead and draw ourselves an angle, just so we have an idea. When you're not given a picture, please draw one, okay? And we're told that QR bisects P, we'll call this PQ, S. Okay, and then we'll call this QR. We'll put an R right here, and that is QR. So that is P. Maybe I should do that in red so it's a little easier to see. P, S, and Q. That is really ugly writing. Sorry. If QR bisects PQS, I'm automatically going to go, well, that means that angle has to be congruent to that angle. These two angles are congruent. Then they tell us the measure of angle PQR is 5x minus 4. And the measure of angle SQR is 3x plus 10. So this is just the angle addition, all right? Solve for x, and then find PQS, the whole thing. Well, not angle addition. You can just set these equal to each other, okay? Because these two are going to be congruent because this bisects this angle. So I'm going to go 5x minus 4 equals 3x plus 10 and just do my solving. A lot of simple algebra here. Subtract 3x to both sides. That's what I choose to do first this time, to get my x's together, and I'm going to get 2x minus 4 equals 10. Add 4 to both sides, and I'm going to get 2x equals 14, divide by 2, and I'm going to get x equals 7. Now I've solved for x, which is what they asked me to do. Finish it. Find PQS, so don't be done. If this is 7, plug it into either one of these. It doesn't matter. Let's plug in here. 5 times 7 minus 4. Well, 5 times 7 is 35. 35 minus 4 is 31. If this is 31, I don't have to plug in here to figure that out. I know this is also going to be 31. So 31 and 31 makes 62. So the measure of angle PQS is going to be 62 degrees. So there are your two answers. All right. On to the next one. All right, you're given, now these are coordinates in a coordinate plane. They're not a point, like on a number line. These, when you see two coordinates, remember always remember always when you see 2 points, it's an x, y. You don't have a simple number line, that would be 1 point. You have an x, y plane, where you have an x point, -3, and a y point, positive 14, which would be way up here, okay? Negative on the x-axis and positive on the y-axis. So that would be point L way up here. And M would be positive 10 and down 4. So M would be somewhere over here. So we need to find the midpoint between these 2 points. And I just drew that for a visual. You don't need it for the problem. Midpoint to me is easy to remember. It's like finding the middle. Okay, so to find the middle, you add the two x values together and you divide them by 2, and then that's your first point, and then you add the two y values together and divide them by 2. You're finding like their average, the middle. Okay, so my x values are going to be -3 and 10. Remember, it's always x comma y. Okay, x, y, x, y. So I'm going to go -3 and 10. Those are my two x values. Add those together. Find their average by dividing by 2. And then my two y values, 14 plus -4. So 14 plus negative 4 is the same as subtracting 4 and divide by 2. So 10 and negative 3, that's going to give me 7. Divided by 2 would be 7 halves. 14 minus 4 gives me 10. 10 divided by 2 is 5. Now you can write this as a fraction 7 halves, or if you want to divide 2 into that, 2 goes into 7 3 times with 1 left over. So it would be 3.5, 5. Either way, these are both fine. All right, so make sure you know midpoint formula. Next one, make sure you know distance formula. Distance formula is derived from Pythagorean theorem. A squared plus b squared equals c squared. And you can do that to find the distance. Remember, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, it doesn't matter which one is your x1 or your y1, as long as you do it in the same order. Meaning, if you label this x1, sorry, that was supposed to be an x, x1, y1, and this point will be x2, y2, okay? Or you can label this x2, y2, and this x1, y1. Just make sure your 2's are together and your 1's are together, all right? So what you're doing by subtracting the x values is you're finding the difference between the x values. And by subtracting the y values, you're finding the difference between the y values, which basically tells you a distance. If I want to find the difference between 4 and 2, negative 4 and 2, negative 4 minus 2 gives me negative 6. That's the difference between these two numbers. That's also their distance, the absolute value of it would be. So from here to here, I'm going to go 6. 1, 2, 3, 4, 5, 6. Now here we don't have to take the absolute value because we're squaring it. That's going to make it positive, and then we square root it. Okay, basically will give us the absolute value. So let's find the difference. Negative 3 minus 9. So negative 3, careful with those double negatives. Now I started here with this one. Since I started here with this one, I'm making this my x2, y2. And this will have to be my x1, y1, okay? You could have started here and gone x2, y2. Just make sure you start here for the y's, okay? So if you start here for the x's, start here for the y's. If you start here for the x's like I did, we have to start here for the y's, okay? So we're going to go x2, negative 3, minus negative 9, double negatives, minus negative 9, and I square it, plus the y's, I'm going to go y2 minus y1, so I'm going to go negative 5, minus, and it's not a double negative, it's just 4, square it. Okay, the double negative makes a positive. Kids get lots of confusion on those double negatives. So I'm going to make that positive. So negative 3 plus 9 is going to give me positive 6. And I square positive 6 and I get 36. Negative 5 minus 4 gives me negative 9. Negative 9 squared, well, a negative times a negative is a positive, so it's going to be positive 81. This is all still under the square root. Okay. So I just brought this down. Now I'm going to add 36 and 81. If I add that real quick, I'm going to get a square root of 117. And you can leave it like that, or you can find the square root using a calculator. If you want to plug this in on a calculator, the square root of 117, it's going to be an approximation because it's not a perfect square. It's about 10.8166, so round to one decimal place, or 10. Oops, I wrote an 18 instead of a 10, 10.8, okay? So that will be the answer to number 20, not 21. So it's approximately 10.8, all right, or the square root of 117. Make sure you know distance formula, okay? Distance formula, x2 minus x1 squared plus y2 minus y1 squared. And then label if you want this to be your x2, y2, or this to be your x2, y2, okay? Make sure you have that down. And we change these to 1s. All right? Okay, name the point on CF that is 1 unit from F. So here is the segment CF. Okay, there's no arrows on that, so it's not the line, it's a segment. And if there was an arrow going this way, that could be the the ray, but there's not. So it's the segment CF that is 1 unit from F. Well, here's F. 1 unit could be G, but it's not a ray. I'm not including G. I just want this segment CF, okay? 1 unit from F would have to be this direction. It's E, all right? Or -1 would be E. All right. Name the coordinate of the midpoint of AG, the segment AG, okay? Because it is a segment, here is A, here is G, this is the segment AG. If I want the midpoint of the segment, I want the middle of the segment, okay? So I can find the average by going -5, this endpoint, plus 1, this endpoint, and divide it by 2. Well, -5 plus 1 would be -4. -4 divided by 2 is going to be -2. So -2 should be my midpoint, or D. D, which equals -2, okay? D should be my midpoint. Now, if you didn't want to just find the average of the two endpoints, you could have counted and gone like, well, I'm going to go over 1, 2, 3, 4, 5, 6. So I have to go back 1, 2, 3 this way, and I have to go over 1, 2, 3 this way, and that would be my middle. You can kind of just look at it, right? Okay, let's go ahead and find what are two other names for angle 1. All right, so how do we name angles? We can name angles by 3 points, right? And you want to make sure your vertex is the center point. So I could name angle 1 as angle WXY, WXY, or I could have named it angle YXW. There you go. Simple as that. Nothing too difficult there. All right, on to 24. If WXZ is 122, what is an expression to represent the measure of angle WXY? So we want an expression to represent this. Well, they've told us that this whole thing here, well, I missed my thing. Okay, they told us this whole thing here, the whole angle, this whole angle here, has a measure of 122 degrees, and that should have degrees there. Sorry about that. Okay. And then they want to know an expression to represent just this, WXY, or angle 1. How could I represent this? Well, this is going to be the whole thing minus whatever that is. So I could say measure of angle WXY is just going to equal 122 degrees minus A. Didn't ask you for an actual value, it asked you for an expression. So that's what it's going to be. This whole thing minus this would give me WXY. All right, name a pair of complementary angles in the figure. Complementary, remember, complementary adds to be 90, supplementary adds to be 180. So remember those two terms. Complement is 90. Okay, that would be this. So an easy one could be, well, 3 and 4. Angle 3 and angle 4 are complementary. Now, if they ask me for two supplementaries, I could go, well, 4 and 5 because they make up a line. I could go 1 and 5 make up a line. Now, ask for a pair, so I couldn't go 4, 3, 2 because that's 3 angles. That's not a pair. So I'd have to go 1 and 5 or 4 and 5. All right. There we go. Okay, guys, that is it. Go ahead and fast forward, rewind, email me if you have any questions, and good luck on this benchmark. And have a good day.